chemistry, we are moving ahead to CO4, which in CO3 we learned about how to use the midpoint formula to find the midpoint of a segment. And the reason we can find a midpoint of a segment is because it is measurable, right? It has an endpoint on both ends, meaning it has a length. We can measure what that length is. Today, we're going to talk about to learn how to find the distance between those two endpoints. So we have the midpoint, which gives us the middle coordinate of that segment. Today, we're going to figure out how we can measure how long that segment is. And this relates very, very closely to the Pythagorean theorem, which we're going to learn in PO 39. So we'll come back to this later on, but for right now, we just want to get this formula down here. So, distance. How would you describe distance? Yeah.
The space in between two things.
Sure. Aiden, yeah?
Like how far it goes.
Yeah, okay, yeah, those are both fine. How far 2 points are from each other. I also don't love the, yeah, oh, another con here, if I have to go to the margin, sometimes I don't space things out very well. If I draw on the margin, it disappears, which I don't know why it does that.
That's
If I, yeah, like on my other board, if I go off the actual Word document, it'll still hold the ink. This here, it just goes away. So I don't know.
Probably fix that.
It probably can. I'm just pointing out things as I see them here. So the distance formula. Remember when you first saw the quadratic formula and you kind of were scared a little bit?
No.
Okay. Don't fret. But I'm going to start this. I don't want you to be afraid. But the distance formula looks like this.
Yep.
Don't worry. Okay, it'll be fine. But we are, again, using the notation for x1 and x2. Like we did with slope, like we did with the midpoint formula, we're talking about the x and y coordinates of two coordinate pairs. And what it is, it's the difference of your x values squared. Okay, the difference of the x values squared plus the difference of your y values
Oh, it's actually not.
It's like
squared.
Pythagorean theorem.
It,
Is it?
yep, yep. It's because of the Pythagorean theorem, yes. Okay, and we'll talk more about why that is when we get to PO 39 with triangles. But yes, if you are familiar with the Pythagorean theorem, then you recognize why this formula works. Okay. This is an order of operations nightmare to try and put into a calculator all at once because of the multiple sets of parentheses, the squaring. So I wouldn't necessarily recommend that you do that. But some of you don't listen to me when I tell you not to do stuff, so you're going to do what you want to do. Okay? But once you get the formula and the order of pairs, it's just plugging stuff in, and then it's the algebra. So find the distance between the 2 points. Look, I can move this up, and the ink stays right where it's at. I like that. I do like that a lot. If our 2 points are 9, 7, and 4, 8, here we have our x1 value, our 9, our y1 value, our 7, x2 value, our 4, y2 value, our 8, and just plugging these things in.
That's pretty easy.
Okay? Let's draw the whole thing out just because we can. So x1 minus x2 is going to be 9 minus 4. That gets squared. Plus y1 minus y2, 7 minus 8, and that gets squared as well.
Oh, wait, this is easy.
Like I said, don't fret by the formula. It looks daunting, but
Wait,
Is there
is it okay if you flip the 9 and the 4?
yes.
Oh, okay.
Why is it okay if you reverse the 9 and the 4 or the 7 and the 8, Aiden?
Because like a negative number squared is still possible.
Because you square it, right? If you get positive 5 here and square it versus 4 minus 9, negative 5, and you square it, you'll still get positive 25. Remember we talked about absolute value last year, or maybe it was pre-algebra, but how a distance can't be negative? How does this formula ensure a distance cannot be negative? Why would you never get a negative solution from this formula, Chance?
The squaring.
The squaring, make sure you have two positive values here. And if you add two positives together, you're never going to get a negative, ever. Okay? So it's impossible to get a negative value because it's impossible for a distance to be negative, and it has to do with the squaring. So anyway, so now we've got 9 minus 4, which is 5, plus 7 minus 8, which is negative 1, and that gets squared, which equals the square root of 25 plus 1, or the root of 26. Okay?
Is that it?
Well, that depends. Is that it?
Well, you can do it, but it's.
Can you simplify the root of 26?
We have to
No.
do this again.
Okay, well, this is why we opened the year with how to simplify roots, because we use roots, okay? The root of 26 can't be simplified, so you leave it in that form. If it did ask for a decimal answer, then you would approximate it, you'd get about 5.1, okay? But that's the gist of the distance formula. Yes? This one, sorry, it's a negative 1 squared.
That looks like a bad 4.
Yeah, it does.
Yeah,
My MB. What?
You did 25 plus 1.
How did I get 25 plus 1?
Yeah.
By squaring 5 to get 21. And then negative 1 squared is positive 1. Remember, when you square a negative, you need parentheses around it, otherwise it's going to give you the wrong answer. But you should probably be able to square 5 and negative 1 in your head without the use of a calculator. Okay. Evan?
So is root 26 the answer?
Yes.
Do we have
If
to
you-
simplify it?
If you could, you would, but you can't. If it asks you for a decimal answer, then you'd approximate it about 5.1. Okay? But yes, root 26 would be the answer. Hugo?
Can you draw on like Google or other places besides Word?
I don't know. Let's test that out.
Yeah, I know.
Wait, can you just like try drawing? Oh, that's
No.
That's not good.
I cannot.
That's just
The bell ringer.
Yeah. The bell ringer, good point.
Yeah.
But that's
It might let you draw in forms.
Yeah.
That's probably a software thing
You
though.
draw in PowerPoint?
Huh?
No, what?
You could probably draw like
one of the other.
Microsoft.
The Microsoft Word things? Don't know about that either.
No.
I can pull up a PowerPoint when we're done here and we'll
Wait, so
see.
are we gonna finish the work? It's
We're not there yet,
26.
anymore. We are still plugging away at this.
Sorry.
Okay? What?
The thingamajig.
It's just one.
So whatchamacallit?
Yes. Girls, shh. I need your legs under the table, so it's harder to turn around. Give you a neck cramp when you're trying to remind you not to. The next one, we have our x1, y1, 10 is our first x, negative 11 is our first y, negative 6 is our second x, negative 20 is our second y, and we begin. Square roots of x1 minus x2, or 10 minus negative 6. Don't forget about those rules for subtraction, subtracting a negative. We saw this with slope as well, okay? They both need to be in there. Negative sign that's part of the formula, and negative sign that's part of the coordinate. Plus y1 minus y2, negative 11 minus negative 20, and that gets squared as well. Okay? And now we start to simplify. 10 minus negative 6 is positive 16. That gets squared. Negative 11 plus 20 is positive 9, which gets squared, which gives us the root of 256, which is 16 squared, plus 81, or the square root of 337. Okay? If we could simplify that, we would. I'm not so sure that we can.
You get like 18 point.
256. Yep, 16 squared. If you wanted it as a decimal, Tatum calculated that for you, so it's 18 something, okay? But otherwise, the root of 337 would be a final answer.
I plugged it in my calculator and it gave me 97.
18.35.
So again, if you try and put this whole thing in your calculator, it's an order of
I just
operations
tried it as an experiment.
nightmare because of the double sets of parentheses. Basically, just so you know, if you do, it has to look like this. So when you type the root key in, you know how it automatically gives you a parenthesis?
Yeah.
That is not the parenthesis for your first set here. Because otherwise when you close that, it's only taking the root of that piece and nothing else. So you have to then make a second parenthesis, then do your 10 minus -6 squared plus another parenthesis, -11 minus -20 squared, and then close that, close the original set. So if you do want to put it all in at one time, you need to remember that this given parenthesis is not the first bracket of this left set.
But it works.
No.
It does not. If you don't,
Yeah,
Yeah,
okay.
no, but it-
yeah, it works.
oh, this works, yes. This does work, yes.
Yeah.
But you have to remember that they give you one, and that's for the entire root itself. Okay? Go ahead and do the next one on your own. I'll write it up here as we go.
Between the two numbers, do we add them or?
What?
What?
I know, but like, that one's like
If we
-11
can
minus
simplify,
-20.
then we have to simplify.
Oh,
See,
-11 minus -20, that ends up being +9.
if we can.
-11 plus.
So what you add?
Wait. Did you get
-11 plus 20 is +9. So we did add them.
It's like,
My mind is.
well,
Okay,
it's a -11 is minus -20.
it's +9.
Why wouldn't you add it?
We did add them.
But
We took -11 plus 20. And the reason why we added is because subtracting a negative is the same as adding.
So why would you subtract from the first place and not be right?
That is part of the formula.
Plus -20.
It's not 11 plus -20. The formula, you're finding the difference between the y's. So you're finding the difference between -11 and -20. And that difference is +9. Just like we had the formula for slope, right? That negative sign is part of the formula. Since our coordinate is also negative, it changes the operation to addition. That's subtracting a negative piece. James?
So, if you can simplify, do you have to?
Yes, if you can simplify and it says leave your answer in simplest word form, then you do need to. If it says leave your answer in decimal form, then you can just calculate it out.
Robbie just says find the distance between.
Why does
The book will ask, the book wants, sorry, Christopher, the book wants answers in decimal form. So, on the test, I will ask for them the simplest word form. Yeah. Go ahead, Christopher.
So why does my calculator give me like a negative number when I'm squaring a negative number?
Are you putting parentheses around the negative number?
Oh, no.
That would be why.
740.
But I could just do that and then just make sure it's not negative.
Yes, you need to do that too. Okay, back to this. We get the square root of -22 squared plus 16 squared. What's 22 squared? Who's got the quick math on that? 444?
484.
That's nifty. 484. I want to say 484 is, yeah.
You don't get a quick math?
That's the 99.
I wanna go outside and play with my buddy.
Luca, comments like that derail everyone and are not necessary, so keep them in. 44 plus 256, we add those together, we get 740, right? The square root of 740?
Yeah.
And what is that in decimal form?
Oh, we don't.
Evan?
That's
27.2.
I have a question.
27.2. Or the root in simplest form. which that one can be simplified. So it's, you can take a 4 out of it.
Yeah, I took a
So it might be better, unless it specifically says write it in simplest word form, might be better just to put it in a decimal form.
Yeah.
Christopher,
So can we just do decimal for everything?
unless it says write it, your answer in simplest word form.
Did it say that?
Evan,
So on my calculator, I'm doing negative 22 squared.
Yep.
And it's giving me a negative.
yes. Are you putting parentheses around negative 22?
No?
You have to.
Just do
Okay.
it.
The reason why?
Order of operations.
Yes. So it goes back to order of operations. When you have negative 20, and this is where I'd love to use the margin, but I can't here. If you've got negative 22 squared, okay, 22 is the base, right? It's what's being squared. The coefficient of that is technically negative 1. Really what this is saying is negative 1 times 22 squared. And if you think about it as negative 1 times 22 squared, order of operations says you should square 22 to get 484, and then multiply that by negative 1, which is going to give you negative 484. That's what your calculator does. With parentheses around this, though, now you're including the negative sign as part of the base, so your calculator is literally going to take negative 22 times negative 22. It's going to square negative 22 and give you a positive 484. Okay, so Christopher just said, well, can I just remember that anytime I square something, it's going to come out positive? Yes, you can, okay? But the reason why without parentheses you get a negative number is because this is what your calculator reads. Okay? Order of operations come into play. Okay, other questions? Your homework
Do we know how to do that?
We have to do time for you.
says, take a look at the landmarks you built in your town in CO3. As mayor of this town, it is your job to construct sidewalks that connect all 4 buildings in a quadrilateral. What is a quadrilateral? It's simply a 4-sided shape. It doesn't have to be a trapezoid, a rectangle, just a 4-sided shape. If each unit of sidewalk costs $65, how much of the town's budget will you be spending on sidewalk? So essentially, what I'm asking you to do here is go back to CO3, where you found the midpoints.
It didn't load.
Where you found the midpoints between these. Now I'm asking you to find the distance. Okay, so you already have the points plotted. The ordered pairs for those points are here. Let me just put them back up here so we can all see here. So we have 3, 6 right there. We have negative 9, 4 right there. 0, 8 is there, and 5, negative 4 is here. You're connecting them in a quadrilateral, so kind of like this. It's trapezoidal, but not a trapezoid. And you want to know how much will it cost you to connect those 4 landmarks with sidewalks, which are essentially represented by those black segments there. So you are finding the distance between each of these 4 points following those sidewalks, and it says each unit of sidewalk is $65. So let's just say that from negative 9, 4 to 0, 8 is a distance of 12. It isn't. Let's just say it is. What would you do to figure out the cost for that sidewalk? If it's a distance of 12. At least you can make it more complicated. Let's say it's 12.37. Okay? If the distance is 12.37, what would you do to calculate the total cost for that sidewalk, Aiden?
12.37 times 65.
12.37 times 65. This represents 12.37 units. Whatever those units are in, it's $65 per unit. Okay? What's that?
The lesson, using the lesson.
Well, what number?
We just learned a formula that's literally called the distance formula.
Oh, you take the unit numbers and that?
You're not, no, you're not using midpoints for anything. In CO3, you kept, like these were the original points, right? In CO3, you calculated the midpoint between each of the landmarks. Now you're finding the distance between each, so you can ignore the midpoints completely. You are finding the distance between the landmarks and then calculating how much it'll cost you to put these sidewalks in.
Are we doing 3, 6, maybe 9, 4?
Yes, the original 4 points. No, not guess and check, Gus. How would you guess and check this? What, that doesn't make any sense. Lee got it, you know.
twice, because
4 times.
there's 4.
You're using the distance formula 4 total times. Because there are 4 sidewalks that you want to build here.
It seems like a lot unnecessary.
Yeah.
Okay? 4 total times. Christopher,
So basically, you just do the 2 points, you find the square root, and then put it to a decimal, and that's.
and then multiply that by 65, because it's $65 per unit. Yes, that's essentially what I'm asking you to do. Okay? Other questions, comments, concerns, complaints, comments, congratulations, criticisms? Just this.
The book?
Nope, nothing from the book today.
And what are we rounding it to? What?
And the time preview, yes. The time preview is part of the debate. Yeah.
Oh, no. Then you're at
Emily.
30. It's
A what?
only 2 decimals.
I know.
What's a what?
You say when you like compliments.
A compliment?
You sound like you're saying compliments.
Sorry, I say it fast. Compliment. Compliment. Yeah. All right, now time math.
Don't forget to like.
Don't subscribe.
Why do you say that?
Yeah,
Christopher?
I unsubscribed.